Check, check. Check one, check two.
Thanks for being here, guys. Enjoy the day.
Greetings. Well, welcome everybody. Welcome again to HouSecCon. This is track 3. There is a really solid set of speakers and presenters here in this track. And also want to point out that we have a vendor back in the back as well, behind now. Yeah, be sure to interact with the vendors and the speakers. You know, without their time and the speakers volunteering, you know, we wouldn't have a conference. So we're going to kick things off here at track 3 with Erik Freeland, who is currently at an SDN startup, Big Switch. He's here to talk about this SDN means security-defined networking. So you're going from development to production with your software-defined networking solutions. He's here to talk to you about the security implications. So everybody give a hand to Erik Freeland.
Thanks, everybody. Appreciate it. It's actually going to be hard for me to talk quietly because I actually don't talk quietly at all. And normally to a room this size, I just scream at them. Now they tell me I have to wear a mic because they're filming it, so this might, I don't know, this might interfere with my mojo, but we'll see. So I'm going to talk today about SDN, and I think the way I kind of put this talk is, so can SDN mean, really mean security-defined networking? As a quick note, that's my name. So I'm actually the director of worldwide pre-sales engineering for Big Switch Networks. So what that means is, yes, I'm a vendor. I will apologize for that in advance. It is actually, this is not a vendor pitch. I am trying to not make this my stock vendor pitch. If you do have questions about that afterwards, I'm glad to talk to you about it. Yes, don't get me wrong. I'm always selling. That's my job. That's what I do. But in reality, what I'm going to try and do is kind of help share some of the things that are kind of happening out there in this space. The best way to put it is networking as a whole is undergoing one of the most transformative times probably in the past 20 years. It really is that big. And I'm going to talk some about it, some of the things that are happening. Well, I get to that in a second. First, a little bit about me, just kind of so you know a little bit about my background, what I've done. I could have showed you the places of all the places I've been fired from. That was actually a good slide. I actually will probably steal that. That is cool. That's me on Twitter. I don't necessarily post a lot on Twitter, but I do make a lot of snarky comments to people on Twitter, like Rothman and other people, so feel free to follow me if you wish. You can email me anytime. I pretty much answer almost anyone via email. My background is I've actually been for 2.5 years with an SDN startup. Working for an SDN startup for the past 2.5 years, you can almost measure that in dog years. It seems like it's forever. I've been all across the world twice. I've talked to tons of customers, and like any startup, you sell next to nothing. So a lot of it's evangelizing and hoping that you can drive the market or begin to influence the market in certain ways. Before that, I actually worked for a security-focused integrator for 10 years. I actually joined that company when they were a very small $10 million company. When I left, they were approximately $750 million. And so even though I, for the most part, work at a networking company today, my DNA is in security. That being said, my DNA in security is I'm a gear guy. I detest policy. I detest process. Can't deal with it. Can't understand it. Hate regulations. If that's your job, more power to you. I'm so grateful for those practitioners that I worked with, simply because I didn't have to do it. So I've always dealt with gear. That's always been my, really what I enjoyed. While that's not me in the picture, I have done that more than once. Many times I didn't even have to have a chair, so you had to sit on the floor. And the worst part when you have to sit on the floor is when you're sitting in the cold aisle and you actually have to sit on a vent. God, that's horrible. It's just horrible. Where you have to go to the hot aisle to warm up and then come back. That's how you know you're a data center person if you've done that before. So Mike actually talked a lot about setting expectations. And I think one of the key parts to this is really setting expectations of kind of what I'm going to talk about and really what I hope to cover. So first of all, this is semi-introductory, okay? I'm not and there's some other talks where people are going to get really in the weeds on stuff. I'm not going to get that much in the weeds. If you want to talk later, we can go as deep in the weeds as you want. I can get almost down to writing code level deep if you want. Likewise, there will be parts of this that are interactive. It makes it much more entertaining if you play along. So please do, like I said, it's just different parts of this. Again, there's no such thing as saying something inappropriate or bad, at least in my conversations. One of the things I'm looking to get across is there's a lot of new ways to look at some of these same problems that we've had for years in security. And some of these things that are changing in networking can actually make them a lot easier. And specifically to that, I'm actually going to talk about 5 specific use cases that SDN is starting to open up, and really to give you some ideas of ways you might be able to leverage some of those concepts as you're looking at future architectures, future products, future solutions, and things you can begin to think of and maybe just kind of use later. May not happen this year, may not happen next year, but you may start to see these things over time. Like I said, for a deeper dive, just find me anywhere. I'll be around here all day. Send me an email, hit me on Twitter, whatever. Glad to talk and tell you whatever I think. Likewise, you know, your mileage may vary. Hopefully you get something out of this. This is actually the first time I've ever given this talk. I only did it because I've known Farnham for forever and a day. And this was something that I was like, well, I think it's an interesting topic. But simply put, guys, I don't know. I live in my own little bubble sometimes. So feel free to shatter it later if necessary. So let me ask this. What is SDN? Does anyone know?
Software-defined network.
Okay, you're wrong. It's actually slide-defined networking. It means whatever in the hell a marketing department says it means. Unfortunately, this is the world today. Imagine cloud 5 years ago. And that's exactly where we are. It's very difficult to define what is SDN. What does it really mean? Gartner's actually come up with a very specific definition. There's a reason I actually use Gartner's definition. Does anyone want to guess why that is? Probably because it's the one my marketing department told them to use. Now again, they get input from a lot of people, don't get me wrong. But they happen to pick the way we view the world. So therefore, we tend to shout that from the heavens. Keep that in mind. Anytime you see things of people replicating what Gartner said, it's probably because you fed them that line, or you know, that's how you operate, so therefore that's right. Otherwise, I don't tend to mention it. But there's a lot of things around decoupling control planes and data planes. There's a lot of moving parts around how you see gear changing. And I'm going to talk about the evolution of kind of where SDN's come here in a bit. But I actually think there is a way in looking at this that there's some huge security aspects that software-defined networking can allow us to really to latch onto that we haven't been able to do in the past. Cool things from dynamic service chaining, micro-segmentation, service insertion, all of these things now that used to be physically difficult to do, or with physical hardware became tough. Now when I look at virtual appliances, being able to steer traffic around, I've got a lot more options at my fingertips than I did before. So I do want to take a step back. And what I actually want to talk about is really this concept of evolution of SDN, where SDN has been and where it is. So the first part, this stuff is barely 5 years old. And by that I mean this is from when the very first companies were formed that had any products around this, and they weren't even really products. Okay, the early stuff that came out, here in the slides, we use the erector set. What I tell people is, it used to be, and in some instances it still can be, you got the 5,000-piece Millennium Falcon Lego set, except half the pieces are missing, There are no instructions. Hey, but that's okay. I'm going to give you a 3D printer, and you can make all the pieces you don't have. Go. That's SDN. A lot of component parts. You got to build it yourself. You got to do a lot of studying. You've got to do some coding. That's what you had to do to bring all of these pieces together. And where you see things starting to shift to is this concept of actual applications, things that you can legitimately deploy. And the market is beginning to shift towards this concept of where SDN is, but even then, it's still not there for every area. There's still so many things that are immature. There's things that if you look at some of the networking pieces that are out there, they're still very immature. But all of this stuff is starting to grow and really, really gain steam, just even over the past year. Probably a good time to talk about this as well. One of the other things that's really driving this is you're seeing a significant shift, as we talk in the term software-defined networking, back to software. So why is that? And when you start looking at what's happening with network switching today, so wish I had an iPhone. If someone holds up an iPhone, who makes that iPhone?
China.
Foxconn makes that iPhone. Granted, Apple does to some extent. Right. It's manufactured by Foxconn. So that HP top-of-rack switch that you buy, that Dell top-of-rack switch that you buy, that Cisco top-of-rack switch that you buy, that insert vendor name here, top-of-rack switch that you buy in your data center, who made that? Yeah, exactly. The answer is Celestica, Delta, Acton, actually not Quanta, or Quanta could have been. It's one of those. They're called ODMs, original device manufacturers. If you actually go to the Acton plant in Shenzhen, China, you'll see a box come down the manufacturing line. When it gets to this point here at the end, if it goes off to the left, it becomes an HP switch. If it goes down the middle, it becomes an Acton EdgeCore switch. That's their house brand. If it goes off to the right, it becomes a Juniper QFabric switch. There is no difference. None. The only difference is the software that someone puts on it. An HP operating system, a Junos operating system. And you're now starting to see companies that are developing these operating systems for these bare metal switches. Everyone's heard of what Google's done with SDN or Facebook. They're basically writing their own code for these switches. That's all they're doing. And what you see is most companies today, they don't have 20, 30, 40, or a couple hundred developers sitting around to develop network operating systems. So you're seeing companies, Big Switch would be one of them, Cumulus, there's others that are out there that are actually now developing operating systems for this metal. So the change that you're seeing in switching today is you're seeing a push from a lot of players to actually further define what is a network switch. How can I disaggregate the hardware and the software? How can I add whatever the software I need on these various hardware platforms? That allows me a lot of choice. I can mix and match whatever I want. Makes it pretty easy to as things grow and scale. Now, one key point in this, for anyone that is more of a kind of a networky background, this stuff is not touching big WAN side stuff, big routers, some of those larger pieces of gear. That stuff's got its own dilemma of things it's going through around what's called SD-WAN. But most everything we're seeing is pretty much it's data center focused, sometimes in the DMZ, and that's the use cases we'll primarily be talking about today. But the key point being, as well, things are moving so fast. 2 years ago, just 2 years ago, none of this existed. Everything I'm talking about with these bare metal switches and what software was doing, 2 years ago, none of that existed. That's the key point, is how fast this has moved in 2 years. Question?
So 2 years ago, you could have done it with the same hardware, or did the hardware have to change a lot?
You could have done it with the hardware. So 2 years ago, people were doing this. The people doing this were Google, Amazon, and Facebook. And the reason they did that is they wrote their own independent agreements with a little company called Broadcom. Anybody know who Broadcom is? Okay, everyone's shaking their head. Good. Broadcom is the people that write the chips for all this stuff. So, excuse me. 2 years ago, Broadcom actually joined a group called the OCP, the Open Compute Project. OCP is actually run by Facebook. And they actually several years ago, they actually open sourced a design for servers because 1U pizza boxes are the most inefficient things in the world. So they actually built a better rack, better power, better distribution, better cooling, better capacity for a 42U rack unit height. They can actually, I think it's now, 60 servers in a rack versus 42 or 44, whatever it is. And 2 years ago, the difference that happened is Broadcom became part of the OCP and all of a sudden was a lot more open with their relationship of what they were doing. So what we do at Big Switch, we're basically writing directly to Broadcom drivers. That's how we write everything on the forwarding plane. On the control plane, that's all stuff we're just working directly with each switch. So what you're seeing before is you had to develop your own custom software. You couldn't necessarily redistribute it. And to that point, I wasn't necessarily going to mention this, but there was an article 2 years ago, and 2 years ago articles are kind of this one was cool because of the topic. It was in Forbes, and it was about the billion-dollar deal that never happened. And that's billion with a B. Amazon was slated, and it committed to buy $1 billion worth of Cisco hardware for their data center. And it turned out, I think they only spent something like 10 million or 20 or 30 million. What they did was they bought bare metal switches, and they wrote their own operating system. I could tell you what they really did. If you want to know later, ask me. I'll tell you exactly what they really wrote, which was really kind of cool what they did. But that's exactly what they did. And they just said, and what these guys have seen is, I don't have this slide in here, but I mainly because it's too self-serving and I didn't want to go that direction, but I'll do it now, is when you look at who's driving networking thought today, who are the thought leaders? The most important people to see is who is it not. It's not Cisco, it's not Juniper, it's not HP, it's not Dell, it's not IBM, it's not any of those fools. It's Google, it's Facebook, it's Amazon. It's Microsoft, actually, as well. Microsoft has slowly, over the past couple of years, become unfoolish again and actually become kind of cool. And the reason they're doing it is their job is to move data. Cisco's job is to sell boxes. Granted, that's kind of my job too, and I'll admit that. But again, it's just a different mentality when how you look at what you're doing and why. So, why are people, and this is my question for you guys, what do you think is driving people to look at things like, new networking technologies or this whole SDN thing? What, if you guys could just take any guess, what do you think is out there? What's driving this? Cost? I'll give you a hint. Speed, good answer, exactly, speed. The real answer would be agility, because we'll talk about speed and agility in a second. Every time I looked up a Google image search for agility, I get like dogs and agility, and it doesn't make any sense, so I liked Keanu better. Mike, like Mike talked about, Mike uses meme generators a lot. Yeah, don't get me wrong, there's going to be a couple of these in here. I also tend to use Google image search, is actually one of my personal favorites, but that's how I do my slides. But yeah, it's kind of speed or agility. Because let's break this out a little bit. From a business standpoint, here's what I need. I need this new application. Whatever this new application is, who cares what it is? It's a new application, it's a 3-tier web application. Web, app, database tiers. You need to load balance the first 2 tiers and firewall between all 3 tiers. Pretty standard, right? This is every app that gets rolled out today almost looks something like that. Now those tiers could be in the cloud, they could be where the hell ever they are. It simply doesn't matter. So what happens is, when this requirement comes up of, hey, go build this. So, all the help desk tickets get created or whatever the process is, and the server team gets this, virtualization team, they go and build these servers. How long does it take the server and vert guys to build this environment? Best guess, anyone? Remember the interactive part. Try like 3 minutes. About 30 minutes on average. Usually I tell anyone anywhere 20 to 30 minutes. Why? All of that's templated. Every one of those servers is a template. Oh, you want the Apache build for that we're having today? There you go. There's your Apache build. Yeah. There it is. It's done. All right. Now let's ask the same question for the network and security teams. How long to build all those VLANs, all those ACLs, all those firewall rules, and all those load balancer VIPs? 3 days, 3 weeks, 3 months. I have heard all of those answers. And they're all correct. That's the problem. Simply put. And look, I'm not saying it's wrong. We've got good reasons why we're here. Good reasons that we've learned over the years why that's the case. But I think this is the key thing, everyone in this room, and the thing I'm trying to, that I would say I've been trying to get across as much as I can is that world is now changing, and it's changing significantly. And everyone's got to start to look at, well, what are these? How are we doing this? Is there a better way? And when you start seeing, oh, yeah, 30 minutes versus 3 days, 3 weeks, 3 months. When everything from the business side, everything is pushing is speed, 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 agility, agility, agility. How can you move faster? How can you do more with less? Why do people move to cloud? Because it's elastic. I can add more capacity instantaneously. So that's what we're all up against. And that's how we have to start looking at this from the security point of view and really kind of starting to understand, well, how does that affect me? How can I get my job done with all of these new constraints that are coming out? And like I said, we all know what the problems are. Everything from change control. You know, God forbid you got to deal with ITIL. Another reason I got out of security. Or, you know, traditional designs or just things like that. All of these really begin to inhibit, you know, what's happening inside of networking. I'll kind of reiterate it here. And everyone has seen this sign at your local mechanic. And we've all seen it, you know, you can have something good, fast, or cheap. Pick two. But there was actually a talk given at an OpenStack summit. I want to say it was about a year ago. And it was actually a gentleman from Disney. And I'll be clear, I actually stole all this from him because I thought it was fantastic. And this idea of good, fast, and cheap, that used to be okay in the past. But it's actually really changed. It's just got to be fast. No one cares anymore. You've got to deliver things quickly. And if you can deliver them quickly, you can usually make them better. And if you can deliver them quickly, you can find a way to make it cheap. And the reason I bring this up is this is how, from an application side, people think, and people are continuing to think. And we all know, living in the security world or on the network side, we're sometimes the last to be told. So I think it's really important to begin to understand how people are really envisioning and seeing how IT moves, because we've got to find a way to keep up. Now, someone mentioned this earlier of, you know, what's driving this and why. This first is, kind of what I show on this left, is this concept of DevOps. I think there is a talk later today around DevOps. And I think it's something that if you're interested and want to know more, they'll probably go really deep into some cool stuff. DevOps means you develop and operate at exactly the same time. You're not doing traditional waterfall development, which is where you all wait, develop, and it all comes over a waterfall and you wait and do it again. You're continuously developing and operating at the exact same time, continuously refining the process. It's what we all do in security. Everyone knows the wheel of security that all of us have drawn up at one point in time or seen in someone's slide or whatever it is, because, hell, over the past 20 years, I think I've seen thousands of them. So we all know that. It's just now this stuff is moving faster. And that wheel is starting to spin up like a little hamster on crack. It's just moving really, really fast. The other concept is automating everything. You know, that's what, when you see some of the pieces that are coming out, well, how can I use Puppet with that? How can I use Chef? How can I automate all of this stuff? Automation is critical. The reason automation is critical is the information we're getting from these, when we go and set up a VM, you know, think about it. Well, then I take the IP of that VM and I give it to someone to write a trouble ticket so they can then write a help request for a checkpoint firewall rule to go do something. That's dumb. Why don't you just spit it out and have it automatically do it? That's what's going on today, is you write a script that automatically sets the VM up, passes the IP back, automatically writes the rule. I know all the components in that. Why do I need to send anything to a human to do that? That's the change that's really happening around automation. Better way to say it, work smarter, not harder. You know, different people have a different viewpoint of this. You know, whether it's lazy or not, you know, I'm not about to argue that, but I will tell you, I wake up every day going, how can I work smarter? Really what I ask myself is, how can I be more lazy today? And if I find something I'm doing 10 times in a day, how can I automate that? Or can or actually now with what I do is, how can I give that to one of my minions and have one of my minions go do that? And then they'll figure out how to automate it or something like that. All right, so hopefully that kind of at least gives you a little concept of some of the things around what's driving this and why. I'm going to talk about some use cases that are out there today. So the first use case is this concept of inline service chaining. So we've all seen things like this. Okay, basically what we're looking at here, I need to put a whole bunch of devices in line as my traffic exits my enterprise. Those could be you know, web proxies, IPSs, firewalls. It could be malware devices. It could be any number of inline devices that are there. It used to be in the old days it was just firewalls. Then people wanted additional, you know, additional devices or other services, and more got added in. And then as you put more things in line, network guys get really freaky about that because I can't control stuff. I don't know what's going to happen. How does this route? They get really on edge about stuff like that. So one of the things that you see coming out is this concept of inline service chaining, but specifically what I'm going to talk more about is this concept of dynamic service chaining. And a lot of things I'm going to talk about with these use cases involve things around dynamic service chaining. I'll play the rest of this out so I don't have to worry about it later. And what I'm talking about is, so as I have traffic that comes from this trusted environment up here to, in essence, into these pair of software-defined networking-enabled switches, I can peel off traffic over to these tools. Now again, we're just using some fairly simple rules at first. Those rules could be based on IPs or ports or things like that. So it's kind of like fancy PBR. You guys are familiar with policy-based routing. Policy-based routing on steroids. But we can actually do even cooler things, you know, around load balancing, health checks, or these devices up. But now here's the difference. Some of you may be out there going, there's tools like that out there today. I know there are. Yeah, I know there are too. I can tell you exactly who makes them. Glad to if you want to talk later. What's the problem with those tools? It's pretty straightforward. They're all ASIC-based. They're all built on proprietary hardware. They're all exceptionally expensive. Running joke I have, if you've ever looked at a Gigamon upgrade, gross national product of a small African country, stuff is horrendously expensive. Why? Because it's all custom-made proprietary hardware. Everything you're starting to see leveraging from what companies like mine are doing and others, we're leveraging this inexpensive, you know, off-the-shelf gear that you, right now, to give you an idea, you're seeing 48-port, 1 gig, 10 gig switches, list price at about $5,000. And it's the exact same stuff that Cisco lists at $30,000. There is no difference. It just doesn't have a Cisco operating system on it. That's a significant cost reduction. That's what you see starting to change this. Oh, by the way, if you're interested in 100 gig, I know 100 gig seems kind of out there. 32 ports of 100 gig, I think the list price we've seen on that is $15,000. That'll be in Q4, by the way. That'll be probably December. It's all a Tomahawk chipset based off Broadcom. This stuff is coming, and it's coming fast. Yes?
Do you see that more like what we have with PCs, where it's just a generic device and you can load whatever operating system you want? And not only that, you can upload what components you want.
So what you're going to see initially, I think, is initially you're going to see the ability to add various operating systems to where, so let's imagine this is one of those 48 port 1 gig 10 gig boxes, and you've got say it's big switch code on it, who cares? And you want to put 100 gig in later because I need that capacity. You can put you buy the metal, you put the 100 gig switch in, the license transfers. Imagine that. Take that old switch, move it over here. Maybe then you want to buy a Cumulus license because you need something that looks like an L2, L3 operating system, and you just buy a $600 license to put on that switch you already own. So what you're going to look at is you're going to see that you can mix and match those operating systems across switches. We're probably a couple years away from that. But yes, that's where things are moving. And the incumbents are going to try everything they can do to not allow that to happen. However, what I do believe will happen, I believe there will be one or two big boys that aren't really big boys, which is not Cisco, that will actually open up their operating system completely. And I expect to see that in 2016. And if you ask me later, I'll tell you exactly who I think that is. Since I'm on camera, I won't, but I got a pretty good idea of who I think it will be. So what you're looking, though, is how can I load balance to tools? Oh, by the way, now with SDN, there's sometimes these controller things involved. Everything's got to be headless. If those controllers die, stuff's still got to work, or else network guys aren't happy. So when you look at this concept of inline service chaining, you can now begin to leaf in firewalls, IPSs, but let me add in another wrinkle. Out-of-band tool farm. Let's imagine this. Let's imagine you've got a FireEye box or some other malware box, who cares, and it's, man, you're running tight on capacity on that sucker. All right, you know what? Start spanning some traffic to it. Span all your traffic to it, and when it sees an alert, now let's do something cool. When you see an alert, call a script. Pass the information to a Python script. That Python script will grab the IP address out of the alert, make a REST API call over to this controller and tell the controller, hey, anything to or from this IP address, send it through this cleaning service. So now instead of scanning everything, I'm still seeing everything passively, but I'm only actively taking an interest in what my passive tool tells me to take an interest in. So this is like your if-then-else from security. Hey, if I see something over here, go do something else. More on this in a second. I got couple more things around that niche. But it's a very easy way to begin to dynamically send traffic to different services. Instead of a lot of these solutions, you're always looping stuff in and out of everything else. Well, maybe one of these is a DLP, and the only thing I use my DLP for is email, because that's the only license I bought. All right, well, why do I want to send all my traffic to that and burn all that capacity up? Just split port 25, shove that off over here, or maybe my POP and IMAP, whatever else, shove all that over there, bring it back in, and send it all out. And by the way, this works reverse if you're worried about DDoS. Yes, there's DDoS solutions out there. How much capacity do you want to buy for that DDoS box versus finding a way to start black holing traffic based on alerts that you see and REST API calls that you can make. So a lot of this is programming based. And by the way, as a side note, I am not a programmer, never have been, never will be. But the good point about it is everybody coming out of school now is a programmer. Every single one of them. If they have any sort of computer science background, they've done enough Python programming that they can pick this stuff up fairly quickly. Because most of these scripts that we look at, they're only about 200 lines. And probably half those lines are just notes on what we did. They're not really difficult. Another use case. I'm going to apologize for this suboptimal picture. I just was, again, kind of trying to figure out how I wanted to relate this. This concept of a public-private cloud interconnect. Let me tell you what I mean by this. This was actually brought to us by one of my customers, who they have multiple points of connection to Amazon, Azure, to Google Web Services, to other third-party, kind of public clouds as well. They have all their internal resources as well, and there's stuff scattered everywhere. And the problem they had is, well, how do I get certain public services to talk to my internal authentication or internal private services? How do I make that happen? What they are stuck with today is the standard way of looking at it. Firewall rules, ACLs, 3 weeks for a change. And after talking with them and looking at how they were doing business, it really became clear that, simply put, what they needed was more automation and the ability to easily dynamically insert various services into flows. I'm going to talk about that in the next slide. But this was simple as being able to say they always had the same services internally. It was always the same authentication services or logging services, whatever that happened to be. And when you needed the access, it was very simple to plumb that access. They were writing the same rules every time. This is a case where you have to look at, how do I automate? How do I do something different? NFV service insertion. Oh, I just said must. This is where I got tired of doing my slides and I forgot to fill this one out. So just as a side note to self, I'll fix that later. Dynamic service insertion. This is the coolest thing in networks ever. NFV, network function virtualization. So what network function virtualization means, let me put it this way. Why the hell do I need a checkpoint firewall over there when I can buy a bunch of checkpoint virtual firewalls over here and just sprinkle them out throughout my private cloud? That's what NFV is. NFV is a way to stop having your hands tied by physical gear. Think about it this way. We've all been in the data center where we say, hey, I got to put a device in this data center because I need a firewall here to firewall stuff inside of this data center. And then you think where all these damn VLANs are, how they're all over the place. How do I physically plumb and get this firewall in the right spot to where it's seeing this traffic and not others? And oh, by the way, does it have enough capacity? And oh, by the way, you just spent $10 million on the biggest SRX box that exists. Do you really need that or not? Don't know. Service insertion says, hey, if we're talking, put a firewall in the middle. If we're talking, an ACL is good enough. And if we're talking, that can go in the clear. And I can do that simply by inserting firewalls dynamically between endpoints that match these traffic profiles. And those are real legitimate firewalls. Those could be physical firewalls or virtual firewalls. They could be SSL decryptors. They could be IPS boxes. It could be load balancers. It could be anything. That's network function virtualization and service insertion. And that's probably, and I apologize, if you have questions or want to dive deeper, please see me later. From a time constraint, I got basically 5 more minutes, maybe 10 at most. But it's the ability to add in all of these components, wherever they may be, across multiple racks inside of a data center. Trust me, you can't do it today. Everyone wants to do it, you want to try to do it, but that's why we have things like these 3-week lead times. Got to make sure the cable's in the right place, the VLANs go in the right place, the IPs are the right way. If none of that matters, it makes it a lot simpler. Good point. So yes, when you're looking at things like this, you're seeing a tremendous amount of what's called east-west traffic. So everyone knows, east-west traffic is when servers chitter amongst themselves in a data center versus north-south traffic, which is traffic exiting a data center or a pod. So what you're seeing is most modern fabrics are actually built and scaled for east-west traffic because this is something that's actually that is very new. The majority of your traffic in a data center now is east-west. That shift happened a few years ago. So it's no longer north-south. It's all east-west. It's all this stuff talking internally. So yes, that's part and parcel of you are seeing an increase of east-west traffic. And a lot of the tricks with this is making sure you're not further impacting a lot of that east-west traffic. So there's a lot of weeds in that question. But yeah, there's things that we're all trying to do to try and alleviate if we're doing hairpinning, or how to take the closest one, and a lot of pieces like that, which a lot of those are there today, but many are still being worked through. So this is one of the things, what I can tell you is, what's every telco in the world looking at? This. Every single one of them. They want to know, how can I have services that are virtual, that I can land in a CO and spin up on the fly and send a customer through it? And if I can do all of that without going to touch anything, we win. So when you see AT&T talk about Domain 2.0, or Verizon talk about Corona, or every other telco around the world, they're all looking at things, and it's all for this reason, which is for, how do I just insert these services on the fly? And likewise, these are also the type of things from a security point of view. Any service can be inserted in line. Again, it's pretty straightforward. A lot of research to be done, a few moving parts, but this is where the industry's moving. I'm going to talk fairly quickly. I already mentioned event trigger monitoring a little bit when I talked about inline, but I'm going to talk a little more about it now. This would be your standard, or in this case, large network monitoring fabric. You've got taps plugged into your production network. You take data off that, you send it to tools to analyze. It's all straightforward. We all do it. We're now starting to see more companies try to gather more data from more places. Largest customer actually we have is Microsoft. In one data center alone, they have like 600 taps, all feeding into a huge network monitoring fabric that's taking that data to a whole bunch of tools for them to analyze later or troubleshoot on the fly. And what event-triggered monitoring means is, let's imagine I've got a snort box. Snort box is just sitting there gathering traffic. But he has one rule where all of a sudden he hits this, let's call it just some bad alert. Could be any sort of snort alert. But in this case, what we're going to do when we see that packet, we're going to make a REST call. We're going to make a REST API call back up to that SDN controller, and we're going to tell it, hey, now anything to or from this host over here, I want you to send all that to Wireshark. And I actually want to see what's going on. So now there's no tickets that have been pulled, because that's normally what would happen. Think about it in a security world. Oh, we got a snort alert. Hey, that's important. Send that to the SOC. SOC creates a ticket. Someone goes, adds it to the monitoring fabric so they can see it in Wireshark. Take every process you've got from a security side and say, how can I not have a ticket there? How can I have this ArcSight box automatically go do something? Because they all can. That's what you're starting to see now with SDN, and what it's starting to bring from the security side is, how can I manage all of these different pieces and bring everything back together and see this data maybe in multiple places? Last thing, and I actually wanted to talk about microsegmentation, because this is actually one of the things that I hear a lot from security people. So has anyone here heard of microsegmentation, or kind of have an idea? Okay, a couple people. So microsegmentation is security nirvana. What I mean by that is, let me paint this picture. So security people, if I could give you a way that a host could only talk to specified endpoints that you determine and nothing else, is that a good thing? Everyone in the world will shake their head as vigorously as they can and go, well, yes, can I buy it today? Shut up and take my money. Problem is it's never existed. It's always been through a firewall, or it's just been, we've never gotten what we wanted out of it. So what you've seen lately is there's been a company come up and talk a lot about microsegmentation and sell you how exactly you can do microsegmentation with their solution, why it's awesome. And it's not bad, don't get me wrong. It does what it says it does. It's a little painful on a management piece, and I'll talk, but that's okay. What you're now seeing happening in the industry is marketing is now becoming overwhelmingly strong with this concept and use case. So as you guys are looking at this, really the reason I'm putting it up here is I want everyone to be very jaded when you start looking at companies with this solution. Because the one that just came up was the concept of macro segmentation. That's marketing at its finest. I will not quote the vendor who did that, but I saw that. It was just this past week, and I thought it was just stellar. So why this is currently a problem, this is what we've been trying to get to at the end of the day. It's the reason we all looked at host-based firewalling and said, oh shit, that stuff sucks to manage. All right, throw that out. You know, we looked at host-based behavioral analysis until kind of like, well, that's noisy, shut that down. So that's where we've gotten to. And a lot of the network challenges with this are, in the past have always been, well, we've got these IPs. These IPs are just here. How do we deal with these IPs on this rack versus this rack has a different set of IPs? It's just tough to write the rules the same way every time when things start to spread out around the data center. SDN's changing that, and it's changing that significantly. So the one key piece is don't use these same old ways of thoughts when it comes to looking at this problem, because what I'll say is there are other ways that people are beginning to solve this, that instead of doing firewalls in a vSwitch, which, by the way, that's exactly what microsegmentation is. It's firewalls in a vSwitch. So I encourage you, when you look at all this, break the problems down to exactly what magic is happening. Because again, there's no magic in any of this. People used to ask me about cloud. It's like, it's not magical. There's silicon sheet metal and software somewhere. Go find it. Same thing with here. If you're doing policy enforcement, where is it happening? Is it happening at a vSwitch? Or maybe you're seeing things like in the OpenStack world, security groups. You know, imagine in this big hunk of metal, in this big set of racks and all these switches and compute, if that VM and that VM are on the same layer 2 network, is that okay? Is that good enough that, well, they can talk whatever's on this layer 2 network, this VLAN, let's call it, all of these endpoints here, well, they're all the same web servers for this environment. Do I need to individually know what that one can connect to? Or as a group, is this good enough because I've now been able to segment my groups properly? That's always been the problem in the past, is I've got too much stuff sprinkled everywhere, especially when you get VMs involved, shit just starts going crazy. And if you can't control where those IPs are and how you're going to manage that, you're going to go crazy. That's what's starting to change. Cool things in that. I won't get any more. My time's almost out. The key point, test a lot of stuff here. Remember, all vendors are liars. That's our job. I'm sorry. That's our job. And you've got to test all of it. You've got to test it and make sure it's really what you expect it to be, and it's really doing what you think. Last thing, I will give a plug. If you want to see any of the stuff I'm talking about or have talked about, labs.bigswitch.com. This is free to use. Sign up for an account. Just please use your work account. Don't use Gmail or Yahoo. We tend to toss those out. But you can play with full live code. You can see everything we're doing for monitoring fabrics or data center fabrics today. And again, it's, like I said, if you want to play, feel free. With that, everyone, thank you very much for the time. I really, truly appreciate it, and I hope to see you later. If you have questions, just ask me anytime today.